This is part 4 of the Unit 4 seminar on geometric sequences. Now this problem is, in my opinion, the one question that gives students the most trouble, and it is trying to find the general term formula when you are given two random terms in the sequence. Now the reason this is difficult, we do not know how many terms there are in total, so the number of terms in the sequence. We don't know the value of the first term. We also don't know the common ratio. So step 1, just a reminder that the general term formula for a geometric sequence is Tn is equal to a times r to the power of n minus 1. And our first step is going to be to use this formula to write an equation for the second term. So I know that when n is equal to 2, the value of Tn is going to be equal to 6. So I'm going to plug that information into the formula, and I get my equation number 1 very quickly. 6 is equal to a times r to the power of 1, because we had to substitute r to the power of 2 minus 1, which simplified to r to the power of 1. We're going to do the same thing with the fifth term. So when n is equal to 5, T5 is equal to AR to the power of 5 minus 1. However, I know that the value of the fifth term, T5, is equal to negative 48. So I'm going to plug that into the equation. And now I have my second equation. Now I've seen a lot of students try to use elimination just like you did with arithmetic sequences to try to solve for a and r. That is the incorrect method. Because we are dealing with powers, exponents, these two equations are not linear relationships. Therefore, we cannot solve these equations using substitution and elimination. Instead, we are going to use the strategy we learned in Unit 1, working with exponents, to solve for r. So I have my my second equation and my first equation, and I am going to divide. So very important here, we always divide the equations in order to eliminate. So I know that negative 48 divided by 6 is equal to a times r to the power of 4 divided by r to the power of 1. Now my a terms cancel when you divide. Negative 48 divided by 6 is equal to negative 8. And when we subtract these exponents, because that is the rule for dividing powers, I have r to the power of 4 minus 1, which gives me a value of r to the power of 3. Now, in order to calculate r by itself, I have to take the cubed root of negative 8. So the cubed root of negative 8 is equal to r, so that's how we get rid of this power of 3. And the cubed root of negative 8 is simply negative 2, so r is equal to negative 2. Now it's not enough just to solve for r. I also have to solve for a, and I can do this by substituting r is equal to negative 2 into either equation 1 or equation 2. It doesn't really matter. Equation 1 is a little bit simple, so ar to the power of 1 is equal to 6. So I know r is equal to negative 2. So negative 2a is equal to 6. We can solve for this question by dividing both sides by negative 2. And when you do that, 6 divided by negative 2 is equal to negative 3. So I have final answer, a is equal to negative 3. Now remember, the original question did not ask simply to solve for a and r. It asked to determine the general term formula. So we have to substitute a and r into our general term geometric formula. We know a is equal to -3. We know r is equal to -2. And the general term formula for geometric sequences is Tn is equal to a times r to the power of n minus 1. So I'm going to substitute the values that I know. And I'm going to leave my final answer as -3 times -2 to the power of n minus 1. This is the correct answer. And remember, the power of n minus 1 belongs to the -2. It does not belong to the -3. Now, I just want to really emphasize that this is the correct way of writing the equation. I see students frequently in their unit guides trying to combine the -3 and the -2 to get +6. This is wrong. I'm going to put a big X next to it. Because the only time you can combine powers, the base, is when the powers you can only combine powers when when both terms have a common base. These are not common, so we want to keep them separate. We can also now determine the first 3 terms of the sequence by substituting n is equal to 1 into my general term formula. So -3 times -2 to the power of 1 minus 1 is equal to -3 times -2 to the power of 0. Now anything to the power of 0 is equal to 1, so my first term is -3. I'm going to do the same thing just to illustrate. That is correct. However, if I plugged n is equal to 1 into the wrong equation, I would get my first term is equal to 1. So it's very important that you remember not to combine the 2 base powers. You're going to keep them separate. So -3 times -2 to the power of n minus 1. And this goes back to Unit 1 when we were working with exponent rules, working with common base and powers where we had to add and or subtract our exponents. So that is completely wrong. Now, the exception to this rule is when your base of your powers are the same. So, for example, 8 can be written as 2 to the power of 3. So now I have a common base and a common base. So I can keep the base the same, keep the 2 the same, and then simply add the exponents. Add the 3 plus the n minus 1, add those exponents. And when you do that, 3 plus -1 gives me 2, and the n remains the same, so your final answer is 2 to the power of n plus 2. Just to be safe for your unit guide and your test, I would keep everything separate unless otherwise specified, but this is the only time that we can combine. Now, this is an example of a problem-solving question. You can do that to practice for your Unit 4 test. And here are a few questions that you might want to cover for homework in addition to the practice test. So remember, good luck on your test and cover all your questions for arithmetic and geometric sequences.